Saxon, Algebra 1, Lesson 99, Solving Rational Equations. Now, first of all, we have to remember what a rational equation is. So let's give you a couple of definitions. A rational equation is an equation where at least one of the denominators has a variable in it. The extraneous solution are solutions that work out on paper, but when we go back and put them in, they don't actually work. This would be, for instance, if I said you have a square, and that square has an area of 4. What are the side lengths of the square? And you say, well, the root of 4 is 2, so it's 2 and 2. I have these side lengths, and you'd be correct. However, there's another square root of 4 that's real, and that's 2, negative 2, right? And so if I said negative 2 times negative 2, that does work out in my equation, although I can't have a side length of a square being a negative 2. So that would be an extraneous solution, or a solution that works out mathematically but doesn't actually work out in real life. And sometimes you'll see they don't work out mathematically when we put them back in. So let's look at example 1a. We're going to solve this. Notice I have this fraction, 3 over x equals 5 over x minus 6. The easiest way to start this is to go ahead and just cross multiply, right? If I cross multiply this, I'll end up with 3 times x minus 6 and 5 times x. Then I need to get rid of this parentheses, so 3 times x and 3 times negative 6, right? This gives us my negative 18. Once I have this, I have negative 18 equals 2x, because I can subtract a 3x from both sides. That will give me a negative 9, once I divide by 2, negative 9 equals x. Now, with all of these, you will want to check your solutions. So I took the time on this one, actually put in a negative 9 back in for x. 3 over negative 9 is negative 1/3. A negative 9 minus 6 is negative 15. 5 over negative 15 is negative 1/3, and this one does check. Now, let's go ahead and move on to 2a here. Same idea, although I'm adding steps, right? This is what we do. So the steps that we're adding here is we're realizing I can't just cross multiply because I have unlike fractions. I find a common denominator, which is going to be 2x. Multiply the top and the bottom of the first term by 2 over 2, which is a fancy version of 1, right? And when I do so, I get a common denominator of 2x. Now I can add these up and say 6x plus 16 equals over 2x equals 11. Multiply both sides by 2x. That gives me that out of the denominator, right? 6x plus 16 equals 2x times 11. 2x times 11 is 22x. I can subtract 6x from 22. That's going to give me 16x. Divide both sides by 16. I'll get x as 1. When I go ahead and plug this in, I say 1 times, or 1 in for x is 3 over 1, which is 3, plus 2 times my 1, which is 2, so plus 16 over 2, which is 8. So that's going to give me 8 plus 3, right? 8 plus 3 is 11, and it does check. Look at example 4. And this is where we're getting into our first extraneous solution that we're going to do here. If I look at example 4, it says solve, and I have x minus 1 over x minus 2, and x plus 9 over 2x minus 4. I'm going to solve this the same way by cross multiplying. So this term and this term together, and this term and this term. That gives me an equation like this. Now I need a FOIL, and this is where a lot of people would stop. Oh, this is too hard, this isn't hard, we can handle this, all we're going to do is FOIL. So 2x times x is 2x squared, 2x times negative 1 is negative 2x, negative 4 times x, negative 4x, negative 4 times 1, negative 1, positive 4. And I do the same thing on both sides. That gives me this equation here. Well, I don't like this because this has got a lot of like terms that I can add up. So I moved everything from this side to this side by subtracting it and collecting my terms. So I said 2x squared minus x squared, right? A negative 2x, negative 4x, minus 4x, minus 9x, right? So I move those over. Or plus 4, and then plus 18, because I moved that 18 over. Once I have this, I start adding all my terms, and I get x squared minus 13x plus 22 equals 0. This is factorable. Don't stop here on this. This is factorable. Once I factor this, I have x minus 2 and x minus 11. Now this is a recent lesson. We learned that x minus 2 is going to be equal to 0, or x minus 11 is equal to 0. So I set each one of them equal to 0. So x minus 2 equals 0, so x is 2. If I move the 11 over, I get x is 11. This is where a lot of people will stop, right? Because I have answers, but I need to check these. So when I plug this back in, I say x equals 2, and let's plug it back into my original problem. 2 minus 1 over 2 minus 2 equals 2 plus 9 over 2 times 2 minus 4. Well, 2 minus 2 is 0, and 2 times 2 is 4 minus 4 is 0. So I have 1 over 11 equals 11 over, or 1 over 0 equals 11 over 0. There's a problem here because this is not, I can't divide by 0. And this one does not work. So for 2, it will not solve my equation. So this is an extraneous solution. I go back and check to make sure 11 is actually real or is not extraneous. So if I plug that in, I say 11 minus 1 over 11 minus 2, 11 plus 9 over 2 times 11 minus 4. 11 minus 1 is 10, 11 minus 2 is 9. Then I say 11 plus 9 is 20, 2 times 11 is 22, minus 4 is 18, and I can reduce my 20 over 18 into 10 over 9. 10 over 9 is 10 over 9, that is true, it does work. So my only solution to this one right here is x equals 11. So I have to be careful with these, looking for those extraneous solutions. The only way I know it's extraneous is to go ahead and plug it back into my original. I can't even plug it in here, because here it would work. Here it's not extraneous. Here it is. And this is where my original equation lies. This is where I have to start.